Hi everyone, welcome to the webinar Why a Multi-Cloud Strategy Matters for Your AI Platform. My name is Hope Wang and I will be your moderator today. So glad to see you all to be here. Before we dive in, I just want to share a few housekeeping notes. We have enabled a Q&A feature here on our Zoom and also a webinar chat here, so you can use them to engage with the speaker or engage with other attendees. Feel free to use them during the session. You want it to be engaging. And we expect this webinar to be interactive. So if you have any questions, messages, just shoot them in the chat. We'll try to answer and comment on them as many as we can. And then you are automatically muted. So if you want to speak out, just you need to send me a message, and then you can use your microphone to ask a question to the speaker. So without further ado, I will hand it over to our speaker today, Tarik.
Thank you, Hope. I appreciate it. Hello, everyone. Welcome to our webinar on why a multi-cloud strategy matters for your AI platform. My name is Tarik Bennett. I'm a senior solutions engineer at Alluxio. I work with a lot of our strategic accounts, and so often very large enterprises, and then sometimes even small enterprises who are looking to architect their platforms for the data sizes that they know are incoming. And so I've seen a lot of different organizations at different stages. And in case you're new to Alluxio, I just want to give you a little quick intro. Is what Alluxio is a very cool technology and cool software that has an embedded file system and some caching technology and some data orchestration capabilities. And these three capabilities together have some very large impacts on organizations looking to do many different things. We'll get into that a little bit today, but I think we should just get started. And so our agenda, I just want to be clear and concise. We have some very large organizations, some very small organizations. There is a lot of overlap, but often what they're doing is they're trying to balance the performance, scalability, and cost. And then we're going to talk a little bit later about, what are the benefits of kind of having an agnostic data layer. And then we'll talk about some best practices for hybrid and multi-cloud and where that's actually coming into play in a lot of the engagements that we find. But the particular scenarios that we're going to address are often, why are people sitting down at the table with us? Why are these small teams or some of these large teams looking to have these big initiatives, or even sometimes other initiatives to accelerate their goals? And one of them is they're looking to manage costs. Other times it has to do with cloud agility or resource availability. And often, more often than not, sometimes it's often about training efficiency, even more than cost. And so there are multiple scenarios that come into play in the engagements that we see. And we're going to talk about many of those and how multi-cloud interacts with those today. So one of the things that we're seeing, and we've tried to find as many quotes as we could find that parallel what we're seeing in these customer engagements, is that AI adoption is ballooning cloud costs. And so by 2028, the adoption of AI will culminate in 50% of cloud compute resources, up from 10% last year. And so what we often see and what we often have conversations about is, the volume of data today might be manageable, but the volume of data 6 months, 8 months, 12 months from now is going to be something that they really need to plan for. And so when you consider that this adoption of AI is increasing, those compute resources, and they're often expensive compute resources, and cloud services in general are increasing. And often, if you see at this next point, global spending on public cloud plans to increase, and that's not just prices, it's also usage. And so usage and prices are increasing. And so you can see that this is something that, very forward-looking data teams or very forward-looking platform managers are looking to get ahead of, because with things like deep learning, the the data sets are large. They're working with internet scale applications, or they're working with huge amounts of telemetry data, and those data sets are ever growing. And so they have to get more efficient, and they have to get more cost efficient to manage them. So where are they? Where are they finding these efficiencies? They're finding them in many different places, not just approaching us, but efficient distributed computing. I'm sure you all understand what that is. There's often some that they may have had GPU idling issues earlier, but they've managed to have some workload scheduling that reduce that. What we have seen quite a bit is because they have these expenditures to improve their platform, they're often moving away from legacy storage or modernizing. And so that's some way to trade a little bit of that cost and build a little bit toward the future. And so we've seen a lot of, and Alluxio has been helping with a lot of those types of engagements to move off of that legacy storage and modernize their data storage for different reasons. And then often minimizing data movement. Sometimes they're in one cloud, but that's not our conversation today. But often their entire infrastructure is distributed, and the data volumes and the amount of data movement and the things like egress fees often increase their expenditures. And sometimes these types of things are not budgeted for. And so platform owners are often looking to minimize that data movement, and then improving data access that can stand in multiple ways, and increasing scalability. They often say that they understand that very large data volumes are coming, and they want to be able to manage that or get the compute resources that they need that may not be available. So there are many efficiencies that they're looking to implement to manage those different incoming and impending costs that they're seeing down the pipe. And so when they have to think about scalability and cloud agility, according to a survey from Gartner, almost 47% of C-suite executives don't feel prepared for the accelerating rate of technological change. I think it's because it's often a lot of money and it's happening very fast. Over the past year, we've had different kinds of conversations with clients every 2 months. And so every 2 months or every 6 weeks, it's a different type of problem that we're addressing, and then it's a different type of problem, and people are working through these issues. And because of the scale and because of the speed, I can see how this is not something that's often very fun. And so getting their architecture to be more agile is something that is often top of mind, and it's often been approved at many higher levels. And so why multi-cloud? This is a multi-cloud talk, but often there are many people who are doing everything in a single cloud. And I think that's probably one for manageability, one for maybe they might have the skill set available to do that. And another is probably for data locality reasons. But we often see many that are strategically moving toward multi-cloud. They may be in single cloud now, but they have another cloud on the horizon that they're looking to bring into their platform or enable their platform to scale toward. And the reasons are multifold. One of them is technical, right? Right off the bat, it improves scalability. You have so many GPUs available when you need them in your current cloud platform. But if you added an additional cloud platform and you're able to provide data there, that totally expands your capabilities. Secondly, is having that platform that can add these different deployments enables hybrid cloud. And what we've seen is with a lot of people who are multi-cloud is that they're often hybrid cloud as well. And we see very long running, or they see a lot of times the hybrid environment or the on-prem environment is running very long model training. It's being used up to almost to maximum capability. It's running all the time, and some of the other environments in different clouds might be periodic. workloads or workloads that are at different levels, but it really depends. It really depends. And so that expanded access to GPUs is incredibly important. And then often best of breed AI tools. When you're multi-cloud, there might, it might maybe not just for AI, but there may be other reasons why people might want to use a particular cloud. And everyone has their reasons, but those are the ones that we've seen most often. But then there are the non-technical reasons, and these can be pretty strong. So we've seen some of our customers that just shift everything to one single cloud, and that is often because they got a really great deal. And so leveraging those cloud negotiations is incredibly important, because when you're working at that scale, the discounts or whatever agreement that you can come into is probably a lot better than any kind of efficiency that you can do by saving here and there on the way that your operations performs. Another is security and governance and privacy, et cetera. Many organizations, if they've built their architecture through acquisition or it's just distributed, they need to ensure that governance and privacy and other situations and other non-technical requirements are carried forth. And then things like service resilience. And one that I did not really anticipate when I first got into these conversations, but one of them was really just flexible access to the most cost-effective resources. And so with some of our large clients, who are very forward-thinking, they've understood that deals can happen at any time. There's a lot of trade-offs, and having a system that is so agile that they can take advantage of cost-effective resources as soon as possible has been a strategic advantage for them. It's not something that every team, every company or organization is mature enough to do, but it is something that in certain situations is very valuable for the organization. And so there is a lot of with that agility, it does not come without any challenges. And so this multi-cloud strategic initiatives that people are implementing, there is some overhead involved. There are some inefficiencies in their current systems that have to be dealt with. A lot of times there's a ton of data replication between data centers or regions. And what some of our clients have understood is that sometimes the data gets sent over and it never gets deleted. They might have pipelines that are never shut down. They probably sometimes don't even remember what's in those pipelines. 1,000 pipelines, things like that. That amount of data replication, when your service is distributed, can often be redundant, and you're paying for all that storage. And so that's an inefficiency there. And if that's a source of optimization. And then often these disruptive, costly or prolonged migrations, they're looking to move off of that legacy software. They would like to have that migration occur as efficiently as possible, and they want to maintain productivity at the same time. And so having to manage that and make sure all those things run on time and hit those strategic deadlines is pretty important. And then obviously the overlapping resources in cloud and on-prem, sometimes it's overlapping compute, sometimes it's overlapping storage. And then again, the non-technical requirements within CSPs, within different cloud service providers, those are all something that have to be managed individually. And so, that's a little bit of the overhead. And that data replication between regions, it's not always small. Sometimes entire data lakes are replicated. This is an example of an Expedia case study that we have, where you can see that there was a good amount of orchestration just to keep the data in sync, because when you're replicating that data has to remain, you have to deal with consistency. And these are large data volumes, and in AI you want to move you don't want to move these very large data volumes around the world. And so this is something that is a challenge for some organizations, especially if they've grown through acquisition and and people want to use the same tools, and you're having to get all that organized on your side and manage it. And these migrations, a lot of times we've seen a lot of HDFS to object storage, and what they're really trying to do is bring data together, or have a little more control, over the access to that data, trying to bring everything under one umbrella if possible. But a lot of times it's just the coordination. What we found is that coordinating between teams can be difficult. Sometimes people that migration reduces their productivity, and all these are very costly issues that have to be managed. And overlapping resources, if you have the same data in multiple places, that's just something that has to be somehow that has to come together in a way that's just a lot more efficient, so that you don't have so many repetitive resources. And again, I think we've touched on this one. And so a lot of what I would call best practices that we found are, because given there are many multi-cloud benefits to AI, and when I say multi-cloud, if they're in one cloud and they're in that cloud 100%, sometimes even a small addition of the ability to get resources from another cloud can have large benefits. They don't have to be on every absolute tool that's available on every cloud, and have everyone on their team completely up on that, expert in every single cloud. But what they need to do is simplify wherever possible, reduce replication wherever possible. And there are cost efficiencies that can be found on things like caching or other means. The data locality is a big issue that we see just because of the data volumes. And so unifying data access across multiple storages, because it's not just distributed, but it's in different storages. And so there's some siloing, and then there's accessing all of the different storage types can be something that if you can bring that together, there's some benefits to that. And rather than just bringing that remote data closer, with AI workloads, throughput, increasing the throughput of commodity storage, you begin to think of things like, how do you improve the GPU utilization, and how do you improve the optimized data loading has been something we've had many conversations of many organizations that are just looking to optimize the data loading. There are some data sets sometimes for even a small company might take 11 hours, to pull that from AWS. And sometimes with the larger organizations, they have bandwidth congestion. And so how do they reduce that? How do they, shift the data to the needed workloads without causing more bandwidth congestion or causing more issues? These are a lot of the areas where people have been optimizing and where we have a lot of conversations. Because I just want to mention that, multi-cloud, I'm not saying that it's very simple to go multi-cloud. There is some overhead, and this is an example from Uber, who's done talks with us before. They've worked with us for a long time, but it's not very, they're at Uber scale, which is very large, but it's not always simple. They don't have a very simple architecture, but they've made strong and consistent use of data orchestration and caching. And so that's where I want to introduce Alluxio and about how we interface with that. And so you may not know about Alluxio, but I'll try to give you the very brief update. You'll be practically an expert by the end of this. But Alluxio fits between compute and storage. And so I think that's why we get into so many of these organizations. That compute might be, cloud compute. It can be on-prem. It can be different clouds. We're going to bring all of that together. We bring that data wherever it resides. We bring it closer to compute. And so you have that data locality, which is incredibly important. And so if you're pulling Alluxio is very smart about this. It pulls the data from other sources, and it pulls it on a very granular level. And so we're talking about only very hot data. And if yeah, let's just say in a model training type workload, you don't want to hit the cloud 1,000 times. You'd rather hit the cache 1,000 times. And so there's some cost benefits to Alluxio in many different scenarios. But because we have this virtual file system that basically pulls all the data from any service, but has all of your data in one area, and so that you can have a complete view of your data, and then we pull that data closer to your compute. That's why we've had many large organizations and many small organizations looking to increase the efficiency of their architecture. We've had many different talks like that. And so we work with many different frameworks, many different things like PyTorch, Ray, TensorFlow. These are all things that we've been doing for quite a while. There's some things like distributed caching. This is a singular data management, and so this management platform. So if you only have one thing to manage, but your data can exist in multiple clouds or on-prem. And so we've had even small organizations who have very few, small teams, right? And they're small teams and they're pushing and they're trying to, hit their deadlines or train as efficiently as possible. They want to reduce the amount of management that any single team member does. And so we often have engagement with them because they just want to simplify their platform and, meet their goals. We will adopt whatever security you have. This is really file level caching. And because every time I mention cache, someone says, is it Redis? No, a lot of the value that we're providing is from leveraging caching on things like NVMe or SSD storage. And so touching on a lot of different areas and, pulling everything together and kind of simplifying it. And so I just wanted to touch on Kubernetes because obviously portability is incredibly important, right? If you want to be in multiple clouds, you want to make this, you want that to be portable. And so Alluxio does have a Kubernetes operator with Helm charts. This is something that most of our clients are doing. And just to mention on the reduced data replication, earlier I showed a chart where Expedia had done they built a homegrown piece of software that was managing the data consistency. But you see with Alluxio, there's just a lot less replication. And so there's a lot less replication. There's a lot of this data, the consistency is managed a lot easier, and there's a lot less redundant data. And so what I've seen in some of the migration challenges and situations like this is that because we're working with hot data, like the hottest, most active data, and there's a lot fewer replications, there are some cost, benefits to, reducing the amount of data storage that you have available, or the amount of data that, you really need to serve to compute. Some of that can be archived. Some of that really just comes into the cache when needed, because obviously it's cached on query instead of just preloading the cache. But you can preload the cache, but most of our clients do cache on query. And there are benefits for caching of sensitive data. So not all data can be persisted in the cloud. Just the thought of replicating some data for some of our clients is just thought of as a security risk. But often security teams will approve something they think of as an ephemeral cache, while other options will be denied. And so if you have sensitive model training data, it hits the cache, that cache feeds the GPUs, that data is evicted from the cache. This is a much more palatable situation for many organizations with sensitive data, rather than persisting that in two places. And so no multiple copies is a strong benefit. But you have multiple deployment options as well. You can have a standalone cluster, and so data from different sources, from different clouds, from different Storage options can be pulled together into that cache. It can be preloaded into the cache or cached on query as part of your pipeline. This a lot of times makes those pipelines a lot more efficient. As you see that we're only serving data that is hot, or data that is, you don't have to anticipate what data is going to be trained. The system does that for you. So you can have a standalone cluster pulling from multiple sources, or you can cache that data locally on the compute storage, on GPU storage. And so what this does is it creates like a virtual Alluxio storage. And so the benefit to this is because the data is shared between nodes, it's pulling less from HPC or from your high performance. And so there are a lot of bandwidth benefits here. We've seen that's been one of the major reasons that people have engaged with us, because if the more data that is being served locally, the less data that is on your network. And so there are a lot of efficiencies like that. So you're using hot data, you're using fewer there's less replication, there's less in the network. So these are the type of benefits that people are approaching us in order to achieve. And then I just want to touch on one quick case study, and I think that's about it. And so speaking of model training, multi-cloud, and training efficiency, we've worked with a company called Juhu. It's a very Quora-like organization where it's a question and answer, and so it's a very large amounts of text, and clients interact with that, and it has an algorithm that does recommendations. And based on the user's interaction with the recommendations, they're fed different content, and that feeds engagement. And so the speed of that engagement is incredibly important. And so earlier, before they interface with Alluxio, they were having their HDFS was overloaded. They were having a lot of network bandwidth use, pushing those models across the network. They had very low training, very low GPU utilization pushing for their model training. And so they had many inefficiencies all throughout their system. And what that resulted in was very slow model updates or very slow recommendations. And so that meant fewer engaged users, and engaged users really impacted the business model. And so, how do you do ads? How do you send ads to users that are not engaged? And so what they did is they continued to work with Alluxio. We added some efficiencies. We increased their GPU utilization. We increased we actually helped them serve some of these models more efficiently to push them out to the different applications. And so all throughout their entire pipeline, we helped to not just improve their performance, but help them help them with their actual business model, because this engagement and the speed of their model training, they were very, very tied together. And so you can see with the amount of deep learning, the amount of algorithmic recommendations that exist today, there are a lot of bottlenecks and rooms to improve performance. And because Alluxio can do things like send data over, do things like orchestration, or on the very low level, increase GPU utilization by leveraging NVMe, there's a lot of Alluxio can fit into many different organization initiatives to improve their performance and efficiency. So I just wanted to touch on that. I hope this didn't go too long, but if anyone has any more questions, we'd love to answer them. But that's the gist of my entire presentation. Thank you very much for listening.